All right, I actually pressed record this time, and we're here with Boris Jabes, and you are program manager on the VC++ team.
That's right.
We've been spending a few, we're going to do a lot more of these because you guys are doing such great work. We want to get more of it on Channel 9. So what do you do? What's your story?
So I'm one of the program managers on the Visual C++ team, like you said, and I work specifically on the IDE. So the IDE features are, governed both by our core Visual Studio team that does a lot of the underlying, all the widgets and kind of the common functionality, but then the language teams like us have to do some of the work as well, and specifically if it's relating to the language, something like Intellisense. And that's where I come in.
Excellent. And Intellisense in Visual C++ is excellent. I mean, it's hard. You guys have solved an interesting problem.
Right. So, providing Intellisense, we've been able to do that for a number of years now, since Visual C++ 6 and C++. But doing it really, really well is, as you said, is not necessarily an easy problem. There are a number of things in C++ that only don't occur for other languages. We have extensive pre-processing happening, which is hard to handle given that it changes. You can have code that doesn't have to be logical, that doesn't have to compile since it's going to be pre-processed away. Or we have an include path, right? We have this idea that you can include another file, like a header file, which is the most common way that people do it, but it can create kind of like a huge chain of dependent files, each of which can affect a piece of code. So, any change you make can have a ripple effect, and being able to find all those changes, and making sure that at any given time you have the right set of things in your auto-completion dialog or, as part of the members of your class is kind of the hard problem.
Sure.
And that's what we've been working to solve, especially in 2005.
Now, do you find that in general C++ programmers rely on Intellisense, or do they typically turn it off?
I think we've seen a bit of both. I think that the main thing is that they will not turn it off if it's useful and unintrusive. Okay. Right. The key is for it to be correct, so they can trust it. It's not if they know better than what Intellisense knows, then that's really not that useful. And if it doesn't intrude as far as performance, right? If it lags too far behind, or if it affects negatively their ability to type into the IDE, obviously they're not going to like it, right?
Sure.
C++ developers tend to be on the kind of higher word per minute type of coder, and so if it's there and it makes them go faster, then it's useful. And I think, given how I see it being used within our team, big on the whole dog fooding concept, that's been the experience. That people are absolutely into Intellisense as long as it
doesn't get in their way.
Exactly.
Fair enough.
It should be one of those things, right? It's just
yeah.
it's just assumed to work well, and it's there.
Well, the great thing about it is if you, for example, are working with a class you didn't write, which is typically quite often the case, you can figure out immediately what its members are, especially if the author of the class happened to actually comment, which is another thing we should talk about, are commenting your code in C++ such that it can be surfaced in the auto-completion dialog.
So, that's one of those things that has come out of some of the work that the C# team did originally, and the CLR team, which is this idea of commenting your code and having it appear as metadata. And this is via what they call this XML doc. And you can put a summary of what your function does, what parameters are, what the returns are, well, the one return. And what we'll do is when you see a tooltip for that function, we'll surface that information. Right?
Excellent.
And that could be from code that is in your project that we can see, or that's been compiled alongside the actual binary, and you can package that.
So you can do that so if you're writing just a native application.
That's right. You can still do those kinds of comments.
XML comments.
That's right.
In a native application.
There won't be the same concept of CLR, metadata that you get in MSIL, but absolutely, what's in the file, we'll still show it in a tooltip.
Okay.
So,
which is helpful because that's typically what I'm programming. I don't code MSDN. I just figure out what the members are and name their name correctly, like do X and Y, then I'm
Yeah.
like, okay, this does X and Y.
And I think that's one of those things that's happened in modern, like in recent times, with these very well formed, very well self-documented large libraries. Post kind of the post C runtime libraries, right? These .NET libraries and other ones like that. You just have to press dot, and you pretty much, it's relatively self-explanatory.
Yeah,
right?
it's wonderful.
But for a lot of native developers, they're still using the classic Windows.h, the Win32 massive library of calls, which is very C style. And there's not that much that can be done there with regards to providing that information and having a hierarchy, because it's really very C style. But at least having that list show the right methods there and the arguments, as well as the ability to know exactly which functions are available to you given your macro state, right? Win32 heavily uses the idea of preprocessors, and a lot of functions are going to be in or out of your scope based on some set of defines. So something like Unicode is a classic, right? You may be in a Unicode state or not, depending on what you want for your application, and that changes the set of calls you can make into Win32, as far as the headers are concerned. And we've done work in 2005 to make sure that you see that list of calls. So we filter that list, that classic dropdown that you get from a control space or by dot, to the list of functions that you can actually call given the state of your code.
Excellent. Very cool. And you had mentioned in an earlier conversation the notion of scoped data.
That's right. So beyond your preprocessor state, right, you also sometimes just want to see what's part of a class or part of a namespace. And the one way people tend to do this, and you can see it often peppered in code because it remains as a remnant, which is typing in this arrow, which tells you what are the members of this. But really, you don't need to do that since those members are directly accessible. But what you want to see is that scope dropdown. So we created a shortcut, which is currently assigned by default to Control J, and it provides you that list.
Excellent.
So it's a very small, list based on which class you're currently coding in, or the class you're currently defining.
Cool. So speaking of shortcuts that you've created, let's take a look at some of these.
Sure.
And I'll just peer over your shoulder here.
All right. So I've got the one I was thinking of showing you was we've got this combo box up here, which is a kind of a VS-wide feature, which allows you to search for plain text. So I can type in main, and it'll find it in the file that's currently open. But what we wanted to do is, like we were talking about how developers tend to not want to get out of the keyboard. They're very quick, and any kind of distraction or any reason to shift their hands makes the feature less useful. So obviously we have a shortcut for it, which is Control D. So you could be in your code, typing away, int x equals 0. And then you want to go find x, and you can just type x by having typed Control D first, and it jumps you to that window.
Cool.
Now, that's fine, and that's kind of that's not too hidden, and you can figure that out. What's harder to figure out is that this box can do a lot more than finding elements in your code. It can execute commands. And the way to do that is to type in Control ? Or Control /, and it adds a greater than symbol, at which point you can start typing open, and it'll try to open a file. So all you got to do is start typing the first few letters, like stdafx, and then it'll give you a drop down of which files you can open, and it opens it up in the editor. And the big thing to know is that these commands that you can call are the same that you can call from the command window, which has always been accessible from View, and then you can find it in your other windows depending on your profile, and it'll be the command window. And this is basically the same thing. I could go open std, and it'll give you the exact same kind of experience.
Okay. Excellent. So it just brings the command window up to what typically one thinks of as the search window.
Exactly. And it's that much less screen real estate you have to give up. It's always accessible. And
you can do it all just from the keyboard as opposed to having to go view, open, other windows, blah, blah, blah. Very cool.
So, other ways that we've allowed you to stay inside the keyboard. Here's a kind of a classic thing people do from within their applications in C++. It can be something like being on a function and saying, well, can I go to its declaration, right, or its definition? In this case, I'm at the definition, right? But I could, oops, there we go. You could have this. You could right-click and say, well, go to the declaration of this, which it will. But now I'm in a different file, and how do I get back? And so, again, from the keyboard, you can just go Control-, and it takes you right back to where you were before.
Excellent.
So little things like that. There's a myriad of keyboard shortcuts, and this is just a kind of a small selection of the ones that we think are kind of neat. And all of these, by the way, can be accessed from Tools, Options, Keyboard. And here you can figure out what does a shortcut do. So Control-, the command is actually navigate backward. Or you could say, well, I know the command, but what is the shortcut? So something like go to declaration, you can just type that, and it'll tell you, oh, it's Control-Alt F12.
Okay.
So I could have done that same example by just saying Control-Alt F12 and then Control-.
Sweet.
So those are things in the editor space.
Good. Well, that's important stuff.
Right.
So, what other things do we want to talk about?
Well, I think debugging is definitely one of those big ones we shouldn't ignore.
Absolutely.
I mean, we spend most of our time debugging, it seems, at times, for large portions of our release cycles. And so, there's big features that we've done for C++ and small ones. The big feature that I think C++ developers will really appreciate is what we call STL visualizations. So we've had visualizations of your data types for many years. It's all stored in this file called autoexp.dat, which is next to Visual Studio. It's in that same folder. And it's a file that essentially says, for given a type, given a struct, given a class name, instead of visualizing it just by, in a watch window, just by showing its internals, what our debugger can see, you could build in some predetermined, style of display. So you could say, you could have a point structure, right, which is int x and int y, and that's it. So what you would usually see in the debugger is you would see something type point, and it will say it has an x variable and a y variable, and here are their values. Okay. Right? But if you already know that it's like that, and you're using it all over the place, you could say, show it to me with just open parenthesis, the value of x, comma, the value of y, close parenthesis. And that's what you'll see as a preview. And so it kind of allows you to do very quick and debugging of your data types.
Sure.
This could be a very complicated struct where there's 100 members, but you really only care about 3 of them. So you could say, just show me those, and I can delve into the rest if I want to.
Nice.
And what we've done is we've brought that functionality to things like the STL. So we build in a number of them, into the IDE. You could write your own, but we also feel that there's a whole bunch that really deserve to be there by default.
Great.
And the STL, that ubiquitous kind of library that people use in the C++ world, with kind of very efficient collections and algorithms, has traditionally been extremely hard to debug, given that its internal, what you would see is its internal data structures, as opposed to the data within them.
Interesting.
And given our technology of visualization, we've essentially been able to display that now. So you'll be able to see a vector as an array. It'll look no different, even though it's a very different structure internally. Or you'll be able to visualize a map as, almost like a table of, key to value. You'll literally see it that way, like kind of like an array, essentially, where there are 2 values that you're looking at instead of indexes. And I mean, that comes for free, and it's just any kind of STL-related debugging becomes 10 times easier.
That's awesome. And this is new for 2005.
This is new for 2005.
Excellent.
This is probably our, kind of our coolest feature in the debugger. But then there's a small one that we've done that I think really deserves to be shown, and it's that one kind of is a wow-worthy, the STL visualizations, but I think everyone's going to discover them, and I don't need to kind of show off how you get to that stuff because it's for free. But there's another one that is harder to find, and it's it's kind of like this. So you know how to set a traditional breakpoint just by pressing here, and it creates that red circle, or you could type F9 and it'll toggle it.
Okay.
But we've said and there's a number of things you can do with this breakpoint beyond just breaking on your code. So you press F5 and sure enough, it's going to break on that statement. But what if what I wanted to do was break only if the value x is 32, or break only when I've executed this statement in a for loop 30 times, right? We kind of provided that functionality for years now as what we call a set of kind of conditions you can put on a breakpoint. So for example, the hit count was the one I was telling you. So you could say, instead of breaking always, break when the hit count is greater than or equal to 32, right? And then that breakpoint will only be will only actually stop when that condition is true.
Sure.
And so that has existed for a couple releases already. But then we've added a major new one now. So I'm going to disable the hit count issue there. Make that break always. And what we'll do is I'll break on return this time. Oops. And there's this new one called when hit. And when hit is a whole new concept which takes our breakpoints to a place we call trace points. So instead of breaking, we realized that a lot of people just want to know that function's been called and want to be able to print out some information. Kind of the ubiquitous Printf debugging, right? But usually that requires you to add a printf statement and recompile. Now you can just print that message as a breakpoint, and instead of breaking, just say continue execution. And then the things you can print out are all these kind of built-in types, built-in values like your call stack or the process ID or the address of the current instruction, and also any value of a variable. So you could say the value of x, as it specifies in that little helper thing. The value of x is, and then just put it in brackets, and it'll evaluate the value of x. And then it becomes a square instead of a circle, and that's to signify that this is not breaking. This is just tracing.
Excellent.
And we call it a trace point. And this is a small feature and just pretty useful when, oh, sorry, I am executing the wrong application. It'll just basically send it out to the output window, and you'll be able to look at that afterwards. Oops. Well then, figures that I would have this happen.
Never fails.
Well, you create a quick app, and of course, I don't. Oh. Well, there we go. Well, I don't want to spend too much time trying to get to it, but I think you get the idea that essentially you would see it in your. Oh yeah, there we go. Include stdafx.h, and there we go. And so now, if I were to run it, it ran. It didn't actually break. And if I look at my output window, I have the value of x is 0.
Okay.
And I mean, this was one of our own developers just needed this functionality, implemented it, and there we go. We have
That's
this,
really excellent.
This is exactly the kind of way that our dog fooding helps us get features that everyone will enjoy.
Sure. That's very cool. So you use custom debugging.
Yeah, I mean, debugging is one of those things that it seems kind of like a solved problem, I guess, but there's still so many little enhancements we can make, as well as big ones, and so we're still heavily investing in our debugger.
Excellent.
We're not done.
Good. Well, as you are in your compiler.
That's right.
Front and back.
And that's pretty amazing. The VC 2005 compiler is one of the best in the world.
Yeah, I mean we've done major new things in optimization, and then we've done a massive, essentially, we've added almost an entire new language, which is what we call C++ CLI. And I think you've had some conversations with
Brandon
some of my
Bray.
colleagues.
He's going to be on Channel 9 soon.
And Brandon can talk about it in depth. But I mean, really, we've made the way you access .NET and the CLR in general from C++ is now far more elegant than it used to be, which makes both pure CLR coding in C++ a reality. I think something that people can do, that make it useful, as well as the entire interop scenario between native and managed code is unsurpassed. I mean, we can do it seamlessly, right? All you have to do is compile some piece of code as /CLR, which is a compiler switch, and that will compile to managed, bytecode essentially, MSIL. And all the transitions between native and managed are done seamlessly for you.
Okay.
You never have to explicitly make a call into native code as knowing what, and you wouldn't have to know. Functions would just be exposed to both native and managed seamlessly.
Excellent. Now that's important. An important distinction to make. It doesn't mean that it's running as managed code necessarily.
That's right.
It's still not managed memory.
That's right.
And that would be incredible to say. Here, I haven't written any managed code, but managed GC, manage all my memory for me.
That's right.
Right. That obviously can't happen. You're talking about making it so that it's exposable.
That's right.
Consumable by
Essentially, we can take kind of standard C++ and have it run as the instructions will now be IL.
Okay.
But of course, if it's accessing memory, if it's doing pointer logic, all those things will still be happening.
Sure.
We don't change the semantics of your code, and you're not going to get garbage collection if you haven't actually used it.
Yes. Now let's talk about that. If I'm debugging, so if I've written a bunch of native code and then I decide to make a managed class inside my CPP file that I want to access great functionality in the CLR.
Right.
So I mark it as managed, or I include the right things, mark my class as managed. And
Yep.
You've made that a lot easier now by just putting a tag on the class.
That's right. The most important thing, especially from an IDE perspective, is for you to be able to do that and still be able to work seamlessly in the editor, right? And in the debugger especially.
Yes.
So, again, the transitions between native and managed, right? Whether it's through DLLs or just within a binary, right? C++ can generate mixed binaries, right? That have native code and managed code in them. And that's a kind of a unique property of our compiler.
Sure.
And our debugger will transition seamlessly. There's a performance cost to pay there, but in slightly slower stepping time. But you still get that. You can transition without even noticing it.
Absolutely. Well, yeah, you just set your breakpoints, and
that's right.
That's a marvelous thing.
Yeah. Yeah.
Very cool. Now let me ask you this: are you finding, since you're a program manager, and so one of your responsibilities is clearly doing a lot of customer interaction.
Yeah.
So, are you finding a lot of traditional C++ developers taking advantage of this new ability to write managed code inline? I mean, are you seeing an adoption of managed code through C++ by C++ developers?
I think the ones that the developers that have looked at it, right? They see this as an elegant way to do a migration. I think it's unclear yet. I mean, we've really just shipped Visual Studio 6 months ago with this new language and way of doing things, and plus a lot of our customer base has extremely old legacy applications. They're not necessarily ready to start jumping the gun and moving towards .NET, but we definitely are doing the best possible way for those specific users, right? The ones that have huge investments in existing code,
sure,
to make their transition as easy as possible, right? And so if they're aware of what we do, right, and that's really the key that we try to push, then I think it's a no-brainer, and they have in general moved towards this model of interop.
Excellent.
Whether that's to start doing C++ CLI managed code and then keep going in that direction, or just using that as a wrapper and then using C# or VB and accessing that code. Both of those are viable techniques. The key is to know about what our abilities are. What I've seen most often is not a lack of desire to do this, but a lack of knowledge on what our capabilities are. The fact that, you know, with C++, you can push your boundary of where it's native and where it's managed to a very fine-grained place. You know, we just talked about a switch, right? /CLR.
Yeah.
That makes your app, makes your code for that file compile to MSIL. You can set that on a whole project. You can set that on just a file, right? We compile in C++ one file at a time.
Okay.
But you can even take a specific file, and within a block of code, you can surround that by what we call a pragma statement, which is pragma managed and pragma unmanaged. And whatever's in between that will be compiled in whatever you specify. So I could be in an unmanaged class and say pragma managed, and it'll put that piece of code
inside the unmanaged class.
That's right, or vice versa.
Sure. Excellent.
And so there you get a huge level of granularity of what's native and what's managed, and no other language kind of gives you that level of control. And when people see that, I think they tend to gravitate towards this.
So now, if I were a library author and I'm writing, and I have written a class in C++, I've decided to write it in C++ for any number of reasons, but I wanted to expose one of its members to the UI guys who are going to be writing something in Avalon, so they're going to use C# or VB.
Sure.
When I put that pragma around, can you put the pragma around just a member of the class? And how would I then access that without making the whole class accessible?
Okay.
Right?
So the key is, in order for it to be accessible from C# or from any managed from the managed world, the DLL that you're handing over has to expose managed entry points, right? Obviously, C# cannot make a call into a native function or a native class of any kind.
Sure.
So what we do is we create that mask, right? Of this actually is this looks managed to you, right? Whatever you specify as managed from that, given the /CLR switch, right, will appear to be managed to C#. It'll look like no different than if it had been written in C#. And then that transition happens. You have to have that, at least that first layer being managed, right? At the topmost of that DLL, there has to be something that's being set to native to managed. And the way to do that is to compile that one file at least /CLR, right? Within that file, though, you could set certain things to be native. So if you really want to reduce the surface area of managed code, right?
Yeah.
But as long as that file has /CLR, things will be able to be accessed from C#, unless you specified it not to be. Right?
Okay, sure.
That's really the idea. I think the way you want to go about this, and you can talk about this at length with Brandon, is you want to start, with some level of manage and see how that works, see if the performance is sufficient, see if you're not doing too many transitions between. The key is to reduce the amount of transitions if it's a very chatty interface, or if there's a lot of data to marshal across. Right?
Sure.
And then you have to just start tweaking from there. DirectX has been tremendously successful in doing this. Right? They provide a managed wrapper on top of the entire DirectX library that they wrote with exactly these mechanisms, and they get like 97% of their performance.
Sweet.
Granted, they're like an I/O-driven, set of APIs, right? It's going to hit your graphic card more than anything else, but it still makes it much easier to program, right?
Yeah. And that's the key, and that's what you've been doing the great work in the IDE.
That's right.
BC 2005.
And I mean, we try to do that for more than just the kind of migration to manage code. We realize that tons of our customers are tried and true native developers. They have no interest in moving away from that, and we can understand that. Game developers are probably a really good example of where they truly need more features in the native side, right? Yeah. And so we continue to improve on that side. One of the big things that we've done in Visual Studio from an IDE perspective, I mentioned kind of the big three areas that we work on, right? The editor, the debugger, and what I call the project system, which is our ability to build your projects from a whole solution, managing the dependencies between those projects and files, and managing the properties, right, for your files, for your projects, like, you know, managing how they should be compiled as opposed to how they've actually built. And you know, one of our selling points is we can say that, you know, we can build huge applications. You know, one of our tests is essentially to build Windows.
Mm-hmm.
That's both a test for our compiler, what it can do.
Mm-hmm.
It's kind of a minimum bar, obviously.
Sure.
And as well as if our build system, if our, you know, can pull it off, then that's also pretty.
So you're saying
awesome.
Build Windows from Visual Studio?
No, we don't build Visual Studio. We don't build it from Visual
Okay.
Studio, mainly because the Windows team has its own build system that's separate from ours.
Completely understood.
Absolutely. But we try to say that we can build code bases of that size. What we can build is all of Visual C++, right?
Sure.
All of the code that belongs to Visual C++ can be built from Visual Studio, right? And that can be command line or from the editor, right?
Mm-hmm.
And one of the big things we needed to do to pull this off, to make managing such large code bases doable, and this was a complaint we had often, was the modularity of properties, right? So if I have 32 projects, you know, in my solution, and I need to make a change with regards to how I optimize these projects, you know, I want to change from /02 to /01, right? I've decided that's how it's going to be. As it was until 2005, you'd have to go into each and every project. You know, that's 32 clicks to go to projects, and change that property each time. We've created now this idea of what we call property sheets, which are accessible from a window called the Property Manager. And these are essentially files, which you can put these properties into the file, and then just include that file from your project. And then all you have to do is select all your projects and say include this property sheet, and you'll get that property for free, right? You don't have to go and set it for each project.
Sure.
And that makes it a lot more manageable when you have, you know, many different configurations or platforms that you're targeting, and you want to make sweeping changes. Then all you have to do is change that file, and you get the change across the board.
That's great.
And that's we're really trying to move towards that model of handling your project properties.
Great.
That doesn't mean you still can't do it the traditional way. That's probably the big improvement we've done, the big new feature we've done in the project system.
Cool.
Yeah.
Well, this is very exciting stuff, and we will continue to talk to the C++ team, because it's important to realize that C++ is evolving in the managed world parallel. And I mean, you guys, you know, you compile the CLR.
That's right.
You guys write the compiler for the CLR. You guys write the compiler for Windows, even though you write it for Visual Studio, and obviously for all products across the company, Office. You are the compiler team.
Yeah.
That's what your main. I mean, besides being a great language team, but you know, you guys
That's
are
true.
you like to build things.
Yeah.
And that's where you're masterful.
And I mean, we want to have a kind of in lockstep. We want to keep the IDE in lockstep with the compiler, right? Whenever these kinds of new neat things happen, we don't want it to be obscure and, you know, find that switch. We really want to expose that as easily as possible. For users, for example, if they're still coming from Visual C++ 6, you know, the dialog that you would use to set your project properties, you know, was like 10 tabs that you couldn't see all at once. You had to move them one at a time. Now we use a much, you know, kind of nicer, slightly larger, obviously, dialog that makes it a lot more discoverable for a lot of these features.
That brings up an interesting question. If I've written a big project in VC6, I'm sure some people are still using VC6. Does it just work 2005? Do I just open it and rock and roll, or is it going to be sort of like the 1.1 of, you know, a project I did in say ASP.NET that I try to open in 2.0 and then I have to run through this wizard and make a bunch of changes?
So there's definitely a number of things that will happen.
Okay.
It is possible that your application will just go. Often you're going to have to do some work with the code, but the reason most likely is between VC6 and today, we've gone from being fairly poor on compliance with the C++ standard to being extremely compliant, right? Because people wanted us to be, in order to enable cross-platform development and just respect the standards. And so a lot of things will stop working in from VC6 code because of that. They'll fail to compile because they're actually not conformant.
And now, are there tools that I could run my code through?
So I guess there's two things at this point that we provide in 2005 as it is. One, there's the trusty compiler warnings, right? For a lot of things, it'll highlight that, you know, this is no longer the way you can access. You can write this code. You probably want to do this instead,
Excellent.
right? Or, you know, we no longer assume that this is what you mean. You know, you should probably specify what you mean here, right? If there's an ambiguity, whereas we used to just assume things, right? And otherwise, we have some documents, essentially, on MSDN. If you go to the first kind of thing about Visual C++ 2005 and what's new, one of the things you'll see is how do I move my code over, right? Because the list is actually quite large of things that have changed. But I've done the exercise with a number of customers, as well as many people on my team have done it, and it seems a lot more painful than it actually is, right?
Sure.
Some things, at first, you know, you'll do a first compile, you'll see a lot of warnings and errors, but the list pares down very quickly.
Yeah.
It goes from a very large list to a small list fairly fast.
Excellent. And you know, what you get for putting in a modest amount of effort is pretty phenomenal. I mean, you get the new great compiler, the great debugging, the great IDE experience.
More security for your code. You know, we've done a number of compiler improvements around that. Biggest one being, and I'm sure Brandon should talk about it, is what we call the /GS switch. And this is a very neat feature which was applied to Windows 2003 SP1. That was kind of the big first usage, I think, from a Microsoft product. And it creates a stack guard. So when something does overrun your buffer, which we can't prevent users from writing that kind of code, it will, instead of just overrunning and then overwriting your return address and going to wherever it wants and executing custom code, will, as soon as the stack guard gets overwritten, which is what's going to happen in this case, will crash the application. We'll end it right there. I mean, it's not the end all and be all. It's not a panacea for security, but it's one very useful step. Another thing is in 2005 we've introduced a full set of replacements for the C runtime functions like printf and stir copy that are secure, that are more secure, right? And they're just essentially the same functions with _s at the end. And we recommend users to switch to those.
Sure. Excellent. And of course there's the static analysis tools that users can use to potentially...
Another thing we've released in 2005.
You got it.
It's a switch on the compiler /analyze, which is what we've been using internally at Microsoft for years now.
Okay.
And we realized that it's useful for everyone, so we packaged it. And this will look at your code and find any number of both security issues or just standard bugs. Right. It's pretty invaluable. We don't ship code without running this.
Excellent. Well, this is fantastic, and thank you. And
Thank
people
you.
can go to MSDN to get more of these tips and tricks.
That's right. I have. There's also a blog that I have where I try to post some of these. It's just Boris Jabes, my alias, and that's the blog.
Okay.
And I should
so you mean
mention,
on blogs@msdn.com?
Yes, that's right.
We'll put a link up on the C9 video.
And I should mention one of my colleagues' blogs because she's been really proactive in putting up some of these tips as well.
Okay.
And her name is Sarah Ford.
Sarah Ford.
And you can find her blog probably more easily than mine. I think it's got a higher
I think we might have had her on Channel 9.
You may have had her on Channel 9. She kind of started a whole before even I joined the company. She started doing like tip of the week kind of thing for Visual Studio, and they all apply to Visual C++. Almost they almost all apply. So a lot of things I present at conferences are some of these tips and tricks, and there's no reason why they should be tips and tricks, right? They should just be things that everyone knows.
Exactly.
And that's what we're trying to do.
Great. Well, hey, thank you, Boris.
Thank you.
Great talking to you.